Hello, so today we are going to do this problem, which is Leetcode 653, part of Leetcode Daily Challenge. So the problem says we get a root of a binary search tree and the target number k, and we want to return true if there exist two elements in the binary search tree that for which the sum is equal to the given target, right? By the way, binary search tree means the left side is smaller than the right side. Yeah, so you can see here, every left side is smaller than the right side, than the parent, sorry, and every right side is bigger than the parent. That's what I meant, basically. The left side smaller than the parent, the right side bigger than the parent. So that's what a binary search tree is, and for this problem, what we are looking for is, let's say we get k equal to 9. We want to find two nodes where the sum is equal to that value. So 3 plus 6, that's 9. So this is a solution. So we return true. For this one, 28, there are no two nodes that sum up to 28, so we return false. So that's pretty much the idea of this problem. So let's see how we can solve it. The solution is actually easy because we can just do DFS, right? And we can just keep a set of the numbers we've seen so far. Right? And as soon as we find a number that is k minus the current value we are looking at, that means we found the sum. So basically, let me actually write this down here. So what we can do is just do DFS. And as soon as we find the number and have a set of values, so first we'll traverse, let's say 5, and then we'll traverse 3, here, and then we will traverse, go to the left side. So this is DFS because we go to the left side first, so we add 2, and then we go to the right side, we add let's say 4, right? And then we go up and we go to the right side, but every time we look at a node, we want to look at k minus that value and check if it's already in the set. If it's already in the set, that means we found our sum, right? So we'll do, let's go back a little bit here. So we'll do first 5. And we check, before adding 5, we check if we have, our set is empty. So we check if we have 9 minus 5, which is 4. We don't have that yet. So we add 5. If we don't, we add 5, right? And then now we check 3. We check if we have 9 minus 3, which is 6. We don't have 6 yet. Add 3, and then we look at 4. Okay, 9 minus 4, that's so 9 minus 4, that's 5. We do have 5, right? So we can return actually true right here. So we can return true here, right? If we had continued, like, let's say, and did 2, 4, right? Then when we get to 6, right, we do 9 minus 6, that's 3. We already have 3, so we return that solution. So that's a solution as well, right? So that's the idea. You just maintain a set, and before, so it's similar to like an array looking for two numbers that sum up to a target, right? We do the same thing. You keep track of the numbers you've seen so far in your DFS, and when you reach a number that is equal, when you find that an k minus the value you are currently looking at is already in the set, that means we found the sum, right? So yeah, pretty straightforward solution. So let's do it here. So we do DFS, and we need the node that we are looking at, and then we need our content that contains a set of numbers that we've seen so far, right? Or let's just call it scene, right? And here we do our base case for DFS. And if we reach like the leaf and we haven't found it, then we can just return false from this side, right, of the DFS. Now, if k minus val is in the scene, that means we found our sum, so we can just return true. Otherwise, we want to add the number, which is value. But here, let me just, it's actually node.val. So let's just call it node.val. And now we want to go to the left side with scene, and we want to go to the right side as well. But what do we want to return? If any side, let's say the left side or the right side, return true, then we want to return true, right? We don't care where the values are, so we want to do OR here so that whenever one of them is true, we return true. And then for the initial call, we want to kick it off with the root, of course, and then an empty set. And that's pretty much it for the solution. And you can see here the way I'm doing this is first the parent and then the left side, the right side, right? So if we submit this passes test cases, right? Yeah, so pretty straightforward solution here. We didn't actually take into account whether they're smaller or bigger than the left side in the solution. But yeah, this one should work fine. Yeah, so that's pretty much it for this problem today. Please like and subscribe, and see you on the next one. Bye.